Okie doke. So, hi, I'm Hannah Mayhew. I've been a stone and decorative surfaces conservator for the last 6 years since leaving the uni. As Pip, hopefully you all heard what Pip said when I first joined. So I'm here to talk to you about the main factors of deterioration I encounter on a regular basis during my work on historic buildings and the main methods I use to conserve them. So within this talk, I've included a couple of small case studies to show examples of how I put these into practice. So next slide, please. So here is a bit of a list of the main factors of deterioration I regularly encounter in stone conservation that I will cover in this talk. So normally, by the time I see a building or sculpture, it has one or unfortunately a combination of these factors, as a lot of them do go hand in hand. So I'll go into each of these and explain a bit about how to prevent causing deterioration when repairing structures and how to slow it down once it's already begun. Just a bit of a note, instead of doing questions after each slide, I'll take questions at the end if anyone wants to ask anything. I was going to do it after each slide, but I think because of the glitchiness of the internet, I think it might be a bit safer to leave them till the end, if that's okay. If not, I think there's you can raise a hand or something and it will come up as text, so I can answer it that way if not. So next slide, please, Pip. So the first deterioration factor I'll cover is water ingress and the freeze-thaw cycle. So here are some examples of water runoff and ingress leading to damage. Water runoff is exactly what you think it is. It's water running over the surface of the stone repeatedly over time, the stone becoming soluble and wearing away slowly. Commonly, this is avoided by creating a masonry overhang or string course, which is it's kind of the same thing as an overhang. It's a jutting out bit of stone above your sculpture to throw water away, a little bit like a small roof. Ooh. So yeah, a little bit like a small roof, and it works in the same way as guttering. When this can't be avoided, sculpture normally ends up looking like the left-hand image above. However, this is over a very long period of time, as this label stopped. It was around 600 to 700 years old. Water ingress and the freeze-thaw cycle are very much linked and a lot more damaging. Water ingress is when water enters masonry through open and unpointed joints, cracks in the stonework and through the natural pores of the stone. Over time, as the water sits in these areas, it will wear away the stone, exacerbating these voids. This then leads to further cracking and blistering of the stonework. This can be detrimental in itself, but if this is combined with cold weather or freezing temperatures, it can be very destructive in very little time at all. As the water freezes and expands, there's nowhere else for it to go but outwards. This can cause cracking, sheeting off of the stone and complete loss like in the right-hand image above. It is for this reason that regular maintenance and repointing needs to be carried out and repairs need to be made to stonework when cracks and losses appear. This should be done using a very soft lime mortar or capping mortar. For repairs, I would recommend a lime putty, hot mixed lime mortar, quick lime or NHL2 mix at most. Any harder and you risk causing further damage to the stone or brickwork you're trying to maintain. You always want to aim to have your mortar to be softer and more breathable than the stone you're repairing. When water is leaving stone, it will always take the course of least resistance. Therefore, by having a mortar that is more porous and breathable than your stone and brick, it becomes the easier path for the water to leave. In the last 60 to 70 years, harder, quicker setting mixes have been more commonly used as there is a mindset of the harder the mix, the better. Most historic buildings were built with hot mixed or quick lime mortar, and have remained standing for thousands of years. Your mix does not need to be hard to do the job. A little bit of a side note is when these more cementitious mortars became available, it was generally in the post-war period when people were trying to throw up houses very quickly, and the main issue that they found was the tending aspect of their mortars. With traditional mortars, you tend to go back for a couple of days after to wet them, cover them, just check how they're doing, whereas with cement mortars you don't have to do that. But as a result, they are harder and they do a more different kind of set. They do a chemical set rather than a crystalline set. So next slide, please, Pip. So sulfation and salts. This is the next factor of deterioration. Sulfation is the black crusty deposits found in the undercuts of sculpture and on ashlar and flat surfaces of buildings. It is in fact pollution deposits from cars and industry that settle on masonry over time from the air around us. This is particularly common in areas of heavy industry and cities where there's more traffic. Sulfation causes trouble with masonry for a couple of reasons. Firstly, it creates an impermeable layer on the stone, which makes it harder for the stone to breathe and for water to pass in and out, causing the stone to stay damp for longer. Also, due to the pollutants, it increases the soluble salt content within the stone. So next, I'll just go over a couple of methods that I use quite regularly for removing sulfation from stonework. So there's quite a few methods of doing this, but I'll go through the top four basically. So first one is laser cleaning, which you can actually see an example of what I've done in the left-hand image. So this is a half and half. So obviously the left-hand side still has the sulfation present and the right-hand side's the area that's being cleaned. So this is probably the most gentle way of removing sulfation, sorry, but it's also the most expensive. So just because the machine's quite costly, but you can hire them. The machine here used is the same as what's used for tattoo removal. However, it was calibrated for the local stonework. So the laser beam or the laser machine, it's an ND-YAG laser. The company that conservation company that we tend to get lasers from is Lincoln Lasers. And it works similar to a microwave. So microwaves heat food and water by vibrating the particles, and the laser does it sort of similarly. It vibrates the darker area that you're pointing the laser at, and it ablates it from the surface. So the next method I'll talk about is abrasive cleaning. This is probably the most commonly used for removing sulfation for its quickness and cost effectiveness. However, it can be quite damaging if not done correctly. So when you're using an abrasive machine, there's a couple that I can think of. There's YOS machines, Ibix machines, micro abrasive machines that are hireable. But your main aim is to select an aggregate that is softer than the stone you're cleaning. So when I've used them in Lincoln and York and different places, you've usually done a survey it's kind of known how hard that stone is. So you want to select an aggregate that's softer than the stone, so you don't bore through the stone, you just remove the sulfation that you're trying to remove. So the next type of cleaning is poultice cleaning. This is quite good as it can be done on both small and big scales, and you don't get the problem with dust in the air that you would with abrasive cleaning. Quite a common one used for removing sulfation is ammonium carbonate in sepia-like clay. This works by you mix the poultice together. It's normally between 2 and 10% ammonium carbonate in sepia-like, which is the clay, and you apply it to the surface, cover it over for 1 to 2 days, and take it off, and then you manually remove the softened sulfation underneath. Finally, and probably the most laborious way to remove sulfation is manual cleaning using a riffler and water. So water is not water. A riffler is basically like a mini file, and you can file away the sulfation. And over time, sulfation is soluble in water. So the combination of the filing of the sulfation and water, you can remove it that way. So now I'll go on to a little bit about soluble salts. So soluble salts are most commonly seen as white fluffy powder on brickwork and masonry, like in the right-hand image above. It can also be present naturally in certain kinds of stone and brick and sit within the natural pores alongside any water that is present. The damaging effects of salts are greatly linked to masonry's wetting and drying cycles, as the wetting allows the salt to become in solution and move through the brick and stone. The crystalline structure of these salts cause similar types of decay to when stone freezes and then thaws. It can cause the face of the stone or brick to delaminate and the surface of the stone to pit and powder. Limestones tend to be the most susceptible to salt decay, as they tend to have a higher salt content. However, Portland cement also contains quite a high level of salt, which can cause the masonry it surrounds to become susceptible, as the stone and brick is often softer and more porous than the mortar. So a couple of ways to reduce and remove salt damage to your masonry. Proper pointing. This way, the mortar is sacrificial rather than the masonry itself. Like I mentioned earlier, a breathable soft lime mortar is always best. This is actually shown in this right-hand image. This isn't what I would class as failed masonry or mortar. The pointing is doing its job by letting the salts come out there rather than the face of the brickwork. Pointing is meant to be sacrificial. It's not meant to last forever. That's why you see people repointing their houses every 30, 40 years. So by the salts coming out of the pointing rather than the masonry, it's a success. It's doing its job. All I would suggest there is brushing it off and removing it from there manually, so it doesn't get reintroduced back into the masonry next time it rains. So yeah, proper pointing, number one. Regularly brushing away of salts so that you don't see, when you do see them on the surface, and disposing of them. Where possible, minimizing the continuous saturation of the stone or brickwork, so you're not getting that repeated salt going into solution. And in extreme cases, poulticing can be done to help draw out salt deposits, and you can then remove it. Next slide, please, Pip. Thank you. So next factor of deterioration I'll go into is biological growth. Biological growth is very common on exterior masonry and isn't necessarily a problem in itself. However, in some cases, it can be a sign that the stone is overly saturated and there isn't enough water being thrown away from the building using guttering or drip courses. So the image above is a bit of a weird case that I found. It shows algae on the interior of a church. This was as a result of the lead being stolen on the roof, actually. So it wasn't actually a failure in the masonry itself, but more vandalism. So water went through the roof, through the woodwork, and then it was sitting in the masonry, which is what caused that algae. So to amend that, you'd have to obviously put the roof back on, let it dry out over time, clean it, and hope that it doesn't go back. So biological growth is definitely worth keeping an eye on, but most of the time it's benign. I'd like to note that it is worth discouraging some plants such as ivy, however, as these can pull out pointing and misshapen masonry over time. So a bit more of a gross topic, but guano or bird poo can be very damaging and is unfortunately very common. The acidity of guano can cause the surface of the stone to bleach and the surface to disaggregate and become pitted, this is sort of shown in the right-hand image above. You can see the back of the beastie has become quite coarse and bobbly. So when possible, it's important to prevent birds sitting on protruding areas of sculpture for this reason and because the diseases bird droppings can contain. If you are removing this, please wear appropriate PPE. So some of the common ways biological growth is removed in conservation are manual removal, simply using warm water and a good scrubbing brush and elbow grease. Then if it's on a bigger scale, what's often used is steam cleaning. This can be done on a small scale or large scale using different types of machines. So you can buy or hire quite small machines called DeRota steam cleaners. So similar to it's basically got a small nozzle and you can slowly clean it off that way. Or if it's on a larger scale, something that I've used quite often is called a thermotech, which is almost like a jet wash, but it also heats the water at the same time. So you get the pressure cleaning, but also the heat, which helps to kill off any algae and that kind of thing. And then biocides, this can be applied to remove green growth or following removal to prevent it reappearing. These aren't always necessary, but can be useful if the area affected isn't easily accessible. So if you know that you're not going to be able to get a scaffold up there for the next 20 odd years, it's always worth using a biocide. So next slide, Pip. Okay, unfortunately, a lot of the time in stone and masonry conservation, you spend time correcting inappropriate historic repairs, most of which are Victorian and early 20th century. So the images above show two common problems I encounter on quite a regular basis. The image on the left shows cracking in a limestone capital and collar. So the capital on the left is Romanesque in date, so from the Romanesque period, and the collar is a later replacement. When the replacement was put in, they used an iron spacer between the capital and collar to hold it in place whilst the masonry is being fixed. Since then, the iron spacer has gotten damp, corroded, and then expanded. As the metal is stronger than the stone, it's the stone that has given way first and has cracked. For good measure, they then pointed it up with Roman cement, which isn't Roman, it's a later kind of cement. So, bit of a side note, historic spaces that were often used and that are often a lot less damaging are timber offcuts and oyster shells, which is always quite nice to find because you know that usually it's quite old if it's been there. So, the image on the right-hand side is from the first slide, which I edited to make it look fancy. But yeah, and it's unfortunately quite a regular occurrence. Like I mentioned earlier, correct pointing is very important for the breathability of masonry to help water safely travel in and out. Here, Portland cement was used to point the wall, and when the brick has gotten wet, a combination of soluble salts from the cement and the freezing temperatures caused the bricks to shatter. This could have easily been avoided by using a more breathable mortar. That way, the water would have gone out of the pointing rather than the bricks, so the bricks here are more sacrificial than the pointing. When possible, it's best to remove repairs as long as you're not causing more damage than the repair itself during its removal. So next slide, please, Pip. So here are the most common methods of repair used when conserving masonry. Before undertaking any of these, you usually remove any surface biological growth, salts or sulfation from your masonry. So I'll go into a little bit of detail about each. So for mortar repairs and repointing, the materials are very similar. They usually consist of 1 part lime to 3 to 4 parts sand or aggregate. That's the most common mix. However, you can have more parts aggregate if you want a softer mix. The main difference between a pointing mix and a repair mix are the types of sands used and where you're putting it. So pointing is for the joints and mortar repairs are on the surface of the stone or sculpture where there's been an area of loss or where there's a water trap. For repairs, you might use a finer aggregate to fit into the cracks, whereas for pointing, it's good to have a good mix of aggregate sizes. So the next one is lime grouting. Lime grouting is when you inject a lime solution into a sculpture or crack, most commonly using a syringe. This helps to prevent water getting into the sculpture, and it also helps consolidate the pores in that area. Quite often, a quick drying solvent is injected first to clean the area and to help the lime to be sucked further into the sculpture. Most commonly, I use IMS or industrial methylated spirits. However, I'd like to note this isn't the purple kind that you can get at B&Q. You don't want to put purple into your sculpture. So, but you can buy 80% IMS on the internet, and it evaporates a lot quicker than what you'd get in normal stores. So I haven't actually put this in this list, but I thought I'd mention it quite briefly. Something I use quite often are consolidants, and consolidants are used when the surface is powdery or friable. They can be used to firm up the surface before you do another treatment or to just slow down further surface weathering. Quite common consolidants I use on a regular basis are primal and nano lime. So nano limes, quite in a summary, are limes in a solvent instead of in water or with aggregate. So another type of consolidant. So I'll go briefly into lime washes. A lime wash, simply put, is a mixture of lime and water used for coating walls. Lime fast pigments are often added for decorative purposes. These do not change what the lime wash is doing, and it's important that the pigments you put in are lime fast, because if you use normal pigments, then they'll fade in the sunlight and due to the alkalinity of the lime wash. Lime washes can be used internally or externally, but if you are lime washing the exterior of a building, casein or tallow is often added to help it adhere. These are done as a sacrificial decorative coating, putting something between the weather and the masonry. Like the stone itself, lime washes are eco-friendly and breathable and allow water to go in and out, but help to prevent it becoming oversaturated. A little bit of a side note, to help against biological growth, some proprietary brands also add biocides to their mix. But you can do this yourself if you want to mix your own. A common one often added is formaldehyde, which is quite nasty, but you only need 1 or 2 drops. You do not need very much at all. And it's also important to note that when lime washing, it's best to keep the area covered whilst it's drying to prevent it drying out too quickly and bleaching. So a shelter coat is quite similar to a lime wash, but it's got added aggregate in. So you can either add this yourself or you can buy them. It works in the same way, but sand's added to the mix, and this is to help fill the pores of the stone that have become powdery and coarse, and to help add an added protection against water ingress. Unlike a lime wash, it's not meant to be decorative, so the main aim when doing a shelter coat is to match the colour to the stone you're putting it on. It's generally known that shelter coats and lime washes can last between 3 and 25 years, depending on how much weather you get on that surface. However, I've seen lime washes that have been on buildings for 200 years, so that's generally a minimum of how long it will be there. Again, these can be bought or you can make them yourself, and like a lime wash, it's best to cover your shelter coat whilst it's curing. Sorry. So pinning and armatures. So pins and armatures can be used when there's a chance that masonry is becoming detached or lost from the building. Because it's quite invasive, pinning is only done when absolutely necessary. This is usually for safety reasons when the masonry is above head height and it's a public building. So to do pins, a hole is drilled through the area that's either detached or becoming detached into an area of solid stone. So the pin is inserted in combination with epoxy, resin adhesives, or a lime mortar. Pins are usually done at an angle towards the building so that gravity helps hold the pin and masonry in place, and the adhesive is there just as an added safety net. So if the adhesive does fail, the pin and masonry are still held in place using gravity. If angled the other way, your sculpture will just slide off the pin, so please don't do that. It is important that pins are non-ferrous so that they don't expand and corrode over time. What I most commonly used and what's generally used is marine grade stainless steel. So this is made for salty, wet conditions, so they have quite a long lifespan. So can you go to the next slide, Pip? So I've just included a couple of examples so that you kind of get an idea of the difference between a lime wash and a shelter coat. So the top left is a traditional bog standard lime wash without any pigment added, whereas below the three sculptures is a shelter coat. So as you can see, they've tried to match it as closely as possible to the stone. So it almost looks like it's not there. So it's just there as an added protection against the weather, sorry. And then I couldn't find a good example of pinning in action. So I found this image of a headstone being pinned, but it is quite good because it shows how the gravity will help hold these pins in place. So next one, please, Pip. So here's my first case study. This was a Lincolnshire limestone corbel. So I'll just go through what I did to it and why, and you can ask me some questions at the end if you like. So firstly, I cleaned some biological growth off the surface of the stone just using nylon brushes and water. Where possible, minimal intervention's always best, so keep it simple. So following that, although you can't see very much in this picture, there's quite a lot of sulfation on the underside of the corbel. So I used an Ibix machine on 1 bar pressure and garnet abrasive powder. We had the limestone tested, so we knew that the garnet powder is actually softer than the limestone, so that's why we selected that. So following that, I'm hoping you can see it in the image, but there's a crack through the centre from the top going into the middle of the corbel. So I grouted that area using just quick lime and water, which I mixed on site, put it in a syringe. I cleaned the area using IMS and then injected it into the cracks. So following that, I used a quick hot mixed lime mortar I colour matched this to the stone, and I capped any areas where I thought water ingress might happen. So I capped on top of where the crack was and also in the middle of the corbel where water I'd seen was sitting. This will help water run away from the corbel rather than sit in there, and then the gaps in it become more prevalent. And then finally on site I mixed a colour matched shelter coat, mainly as well because lots of birds like to sit on top of this corbel. So to help protect against the acidity of bird guano and to add a bit of protection from the weather, I did a colour matched shelter coat. So next slide, please, Pip. So the next case study is a 17th century magnesian limestone coat of arms. So the picture on the left is actually during treatment, but I'll explain in a minute why I've chosen that image. So firstly, I water washed the surface to remove biological growth. This was just with nylon brushes and warm water. It did the job. So again, keeping it quite easy. So here, because it was quite a public site, we didn't use abrasives. We decided to poultice off the light sulfation. So we did an 5% ammonium carbonate poultice in sepia light clay, applied it to the surface of the stone and left it overnight. The next day we came back, took off the poultice and just scrubbed off the softened sulfation and neutralized it by washing it off with water. So the little, I'm hoping you can see it, but the little grey flags that are on that is actually the location of where I've put pins. So it looks quite scary with lots of pins, but because this is actually over a doorway, we couldn't take chances of anything falling off, basically. And also this kind of deterioration is quite common with this kind of limestone. So magnesian limestone almost becomes like an eggshell over time. So each of these areas are separate areas that are fractured from the whole. It also didn't help that instead of it being along the natural bed of the stone, to get the size of the stone they needed for this coat of arms, they did a face bed, which is, so if you imagine that stone's formed in layers, so it's strongest if you take it from these layers, but they've taken a sheet off the top to create this, which is why it's naturally a bit weaker. So yep, each of them is a very small 2mm pin that we put in. We put this in with epoxy adhesive, and then once all the pins were in place, we then did colour matched lime mortars on top to make sure there wasn't any water ingress into where we put pins. We also repaired the top of the little crown. I hope you can see it. Looks a bit different in the first one to the second one, as we were able to find bits that had previously fallen off and reattach them. Then finally, we did a colour matched shelter coat. We matched it to the stone around it. We chose here actually not to, so I'm hoping you can see along the border, there's actually a really nasty Portland cement. Here we chose to actually leave it in place because of the way the stone coat of arms had fractured. We were worried that the vibration of taking out this cement would cause more damage. So we've chosen to leave it in place here just to prevent further damage, although it's not ideal. So next slide, please, Pip. So here I've got a few a little bit of bedtime reading if anyone wants it. These are all books that I've used quite a lot, the 2 English heritage books and the Nigel Copsey book, if anyone wants to learn a bit more about hot mixed lime or quick lime. The other ones go quite a lot into the different types of mortars used and why, and different mixes and stone in general. Also, if anyone would like any further advice or would like to know where to buy materials if you want to work on your own buildings, I'm quite happy for anyone to email me if they'd like. If not, thank you for listening. And does anyone have any questions? I'm not sure if people can switch on their microphones if they'd like to.
Yeah, hopefully I've stopped sharing my screen, so hopefully everyone should just see Hannah now. Thanks, Hannah, so much. That was a really, really informative talk. And yeah, if anyone's got any questions, pop them in the chat. I can see one from Jenny. Jenny, if you've got your microphone on, you can ask that one in person if you like.
So, yes, hello, Jenny.
It was when you were talking about the cleaning of the stonework, and it might be a really silly question, but I wondered whether the sulfation is always softer than the stone, or whether when you come to clean the stonework, actually could it be more damaging?
So it's not always softer than stone, but it's normally a quite different consistency. So what I would probably do is then tailor my cleaning method. So instead of using an abrasive, I probably use a poultice because it's not actually abrading the surface and it will only take off the sulfation. So the chemicals in a poultice, so an ammonium carbonate poultice, they won't have any effect on the stonework. So if I wasn't sure, I'd probably do that rather than rather than a more aggressive clean. So
Thank you.
Sorry, that's a bit of a waffly answer, but
Thanks.
Great. I think John has his hand up. John, did you have a question?
Hello.
Hello.
I just wanted to ask, how many of these solutions could be self-administered, or how many would need to be applied or professionally administered?
So is that for sulfation or just the treatments in general?
Well, more of a general question, really.
Most of these, other than say lasering, you can do yourself, but I would definitely always suggest having a practice first on something a bit less obtrusive. But yeah, like I put my email in there, but there are companies where you can buy test kits. So for sulfation, if you think it's sulfation on your house or home or a building you're working on, you can get test packs so you can try them out yourself and see what works best. I would just suggest wearing PPE if obviously if you're using a poultice, you don't want it on your hands, and it's always best to wear a mask. So I would always try and be as careful as possible, but I think most of these can be done yourself.
Okay, thank you.
Okay.
Great. And Sylvia had a question about tinting shelter coats. Sylvia, if your microphone's working.
So the sands itself, so if you're mixing it yourself, you would, so I'm trying to think of the easiest way of explaining it. So you can either buy shelter coats which are pre-coloured, but what actually colours the shelter coat is pigment, so lime-fast pigments. These tend to be mineral-based pigments, so earth pigments, so natural. And the sand itself will also change the colour. So if you put a fine aggregate into your shelter coat and test it out on your stone, that will also colour it. You can, you can also add stone dust to your shelter coats, which also colour it. So there's different ways of colouring it, but it's in the same way that you'd colour a lime wash, you can colour a shelter coat effectively. So that's what I'd do. It's also worth noting if you're mixing your own lime wash or shelter coat, the easiest way to add casein, which is what helps it stick to the exterior of a building, is actually using skimmed milk. So that's how it's been done for centuries. So you don't buy casein powder, you do half and half water and skimmed milk and then add your lime. So sounds a bit yucky and it can be a bit smelly, but that's how it's been done for thousands of years.
Thank you.
Thanks, that's really helpful. John, I'm not sure if your hand's still up from last time or if you had another question.
No, sorry, I should have lowered my hand.
That's fine, that's fine. Hannah, what's been one of your most sort of challenging treatments that you've done?
Ooh, probably, well, I wouldn't say necessarily challenging, but one that was probably the biggest was when I was working at Lincoln Cathedral. So I was laser cleaning for 3 years. So that's quite a long time. So it was definitely a labour of love, but it was also very pretty. So it was definitely worth it. But I was doing the Gallery of King Sculptures at Lincoln Cathedral. But I think kind of each project that I go on has different things you have to work out. It's very rare that there's an easy or quick solution. You can plan as much as you want to plan, but there's always things that pop up. So yeah.
Thanks so much. Are there any other questions? Oh, yeah, got another question from Sylvia. How do you get poultices to stay on vertical surfaces?
They're sticky, so they tend to not have any trouble staying on. They're most of the time they're kind of like pasty in consistency, so there's normally not any trouble trying to get poultices to stay on surfaces. They just stick.
Brilliant, thanks. Yeah, Tim said like a face pack.
Yeah, I was actually going to use that as an analogy, but I thought I wasn't sure if everyone would appreciate that. But yeah, they are like a face pack effectively, and then you can use different things like cling film or plastic wrap to cover them up to stop them drying out too quickly.
I got a question from Mark. Can you explain how you pinned the coat of arms? Did you drill down and then drop the pins in with resin?
So I was trying to explain this when I was doing the talk. So most of the time, say if you, sorry, I don't know if people can see me or not, but so say you're pinning on a vertical surface, sorry, I'll just use this pen. You drill downwards into the good stone. So the bit that you know sound, you'll drill at an angle down. So although the little flags look like they're coming out this way, they're actually angled very slightly down. So that when you pin, say if a bit was to come off, it will stay in place because of the gravity and the angle of the pin. So firstly, you drill using a very fine drill bit or diamond tip drill bit. And always keep the pin as small as you can. You don't want to damage more stone than you need to. So you drill into the surface of the stone, and then using the pin, you measure that it's the right length. So then you cut the pin to the right length, try it, make sure that it's correct, so it's not protruding and it's not too short, because if it's too short, it's not going to do the job. Then you either roll the pin in the adhesive, or you put the pin in and then squirt the adhesive around it. So you've got adhesive lime or around the pin when it's actually in the hole. And then it's important to, once you've done that, you cap the almost tube created by the pin and the drill hole, so that water can't get in. But I would only suggest pinning where absolutely necessary.
Thanks, that's really helpful. And when does it get to the point when you can't conserve it and when you have to start replacing things? Is that a decision that you make as a conservator, or is it a sort of a larger sort of discussion?
A lot of it, I'd say most things are conservable in most of the time. So it kind of depends whether it's a functional thing or if it's decorative, because obviously if it's functional, like a door jamb or something like that, it needs to be quite hardy. But if it's sculptural, most of the time it's conservable, or you can, if worst case scenario, you can remove it from the building but still keep it or put it in a museum. Or so most things are conservable, but it tends to depend on, is this masonry serving a function or is it decorative? When possible, you try and make the decision as a team. If it's a private owner, at the end of the day, it's their decision. But if it's a commercial building, then it's usually a decision that tends to be, you sort of build your case to the architect usually.
Thanks. Any more questions from anyone else? I think we're good. So I'll just finish off with the final question that I ask everyone, just to round this talk off. What's been your favourite sort of building or project that you've worked on?
I'm not sure. There's so many. This week, I don't know. I like normally when it's a combination of stone and painted surfaces. That tends to be my favourite. I like it when it's there's a few different problems to solve. Don't know if I've got a favourite. It's like picking your favourite child.
I think you know when you're in the right job when every project's your favourite project.
I mean, I obviously don't like it when it's raining sometimes and I'm outside, but I don't know. It is like picking your favourite child. I haven't got a favourite.
That's a great answer, thank you. So yeah, I think if no one has any more questions, we'll round this off. Again, this talk's been recorded, so it'll be available later on YouTube, and once that's up in the next couple of days, I'll send you all out the link to that as well. I think there are a few people who registered but couldn't make it, so I'll send them that as well. Please feel free to share this with your colleagues or whoever else you think would be interested. And again, Hannah's email address was at the last slide, but if you want to get in into contact with her, you have my email address, and I'll forward your question on to Hannah as well. So I think we'll finish with saying a massive thank you to Hannah, and yeah, thank you so much to everyone for joining.
Oh, hi. Thank you. Okay.